Next, we will move on the filter circuit. Before going to the filter circuit, first we will check out what is this filters mean. In the real world also we are heard so many times these filters. Suppose we will take as a one example as a water filter. So what this water filter will do and what are the operation of this and what is the definition we can say that with respect to water. So usually water filter, it will give you the pure water, that is the one operation. Another one we can say in another words the same thing in water filter, it will block unwanted particles in the waters, or we can call bacteria, some other things, it will block or it will remove from the water. This is what the filter operations. So here we can note that the filter will operate two things. One will, it will give you, that means pure water it will give you means it will give you the particular selective part, and second one, it will block unwanted. So we can say easily filter has two operations. One, it will pass the selective things, and second one, it will block the unwanted. So definition of filter is, we can say that the circuit which pass the selective portions and block the unwanted portion is known as filters. Now here we will discuss about filter in our analog circuit. So if you take one sine wave, suppose we are taken, this is one sine wave. Here usually we measure three things. One is, we know that it is a height, we can call it as amplitude, and width we can call it as either time or frequency, and anyway we have phase, that means we start at 0 degree 180 like. So up to here we are discussed many on amplitude, how to increase amplitude, amplify gain, everything. So now the filter is actually, the thing is only for frequency portion. So we are talking about the frequency, and the whatever frequency operation we are doing, that is nothing but in the filter. So filter we are not alternating anything in amplitude or phase, only we are altering frequency. So suppose we have different frequencies, like this is one frequency, this is another frequency, or something like that. Okay, this is suppose one signal we have different frequency here. Here we have one frequency, here another frequency, here we have other frequency. So in the circuit we can say that we want some particular frequency to pass, that means F1, and other frequency we have to reject or block. So this type of operation we are calling as a filter. So we can simplify filter is that filter is nothing but particular frequency is passed and particular frequency is blocked. So this operation is known as filter circuit. So usually in filter we have two types. One is we are calling as a passive filter, another one we are calling as a active filter. So usually the filtering operation we are using either resistance or capacitance. Anyway resistance required, resistance and inductance, and resistance, inductance, capacitance. These are we are using. Only if you use these resistor capacitor or inductor resistor or inductor resistor capacitor, then this type of operation is known as passive filter. Active filter means with these three, that means RC and RL and RLC, we are using op-amp. Okay, that means op-amp plus RC, op-amp plus RL, or op-amp plus RLC. This type of circuit usually known as active filter. Simple way we can say that without op-amp or without amplifier, whichever circuit we have, filter circuit, that we are calling as a passive filter. Whichever circuit included op-amp or amplifier, that circuit is known as active filter. So what are the classification we can do in filters? Usually here we are discussing about what is actually active filter work. Okay, so in the, because op-amp portion we are discussing more on this. So in this, what are the filter possible? So if you take as a frequencies, in this frequency, what are the type of frequency we can pass and what are the type of frequency we can block? So in this we can say that there is a operation regard four types. So what are the four types? We can call, the first type is called as a low pass filter. Name itself says that the low frequency which one is passing, that filter is known as low pass filter. Similar way, high pass filter. So in this we are passing high frequency, and another one is band pass filter. Band means some particular area. High and low means what? If you take one frequency range, suppose here we are taken on frequency range, this is the frequency, okay. This frequency range if you are taking, so this is your low frequency, okay, and this is somewhere your high frequency. I want in between this portion only, some particular area only. I don't want, if you are talking about low pass, only this low pass signal is passed. High pass means somewhere upper portion of this. I want particular area, that is called as a band. So some particular region only I want, that is called band pass filter. Similar way, the opposite of band pass filter we can call as a band reject. That means one particular area I want, all the area I require. For that we call as a band reject filter. So these are the 4 types of the filter we have. First we will discuss about what is low pass filter and how it operates. A low pass filter is a filter that passes frequencies from 0 Hz to some particular frequency and significantly attenuate or reject or block all other frequency. So one question usually arises, what is low frequency means? Here we are telling about the frequency like low frequency or high frequency, like that. How you know that this is the low frequency? How you know that this is the high frequency? If you take example in your academic passing mark, how we can say this person is pass or this person is failed? There is a one particular cutoff marks we have. Anyone score less than that cutoff marks, we will say he is fail. If anyone score more than cutoff marks, usually we say pass. So that cutoff marks, usually you know that is some way we will take example of 35 marks. So we will say there is a 2 things. One is fail, which is less than 35, okay, and pass we can say which is greater than 35. So we can make from this particular cutoff marks, we can say that he is fail or pass. Similar way, we are taking one cutoff frequency here, that is called FC. Okay, so this is very important. This cutoff frequency according, we will make that is it particular signal is low or high. So very simple, low means which is less than cutoff frequency, and high means which is greater than cutoff frequency. So from this we can say that low pass or high pass. So how it is actually, if you take one diagram, suppose here we are taking gain versus frequency. So usually what happens, I am getting for all the frequency, suppose I will take this one frequency, this is gain. Usually gain, if you want in unit, we are taking in dB. So dB is nothing but logarithmic functions. So 20 log of whatever gain is there, that we can call in gain in dB. So suppose say that this is your gain, nothing but V0 divided by VB. So usually you are getting all the frequency, some gain like that, assume this. So here we are taking one cutoff frequency like this one is FC. What happens if you use low pass filter to this portion? When you taking this one, the gain is this way, okay, and we'll call this one is FC. So what happens, only the FC portion is passed and other portion is blocked. Blocked means we'll take as a 0 of that one. So this one we are calling as a pass band, this one we are calling as a stop band. So this gain and this gain remains same, but stop band the gain become 0. So previously what we have discussed, filter means it will pass some selective, block unwanted. In the low pass filter, it pass the lesser than cutoff frequency and block the higher than cutoff frequency. This is we are calling as a ideal response of the your filter circuit. So now how to calculate this FC or how to design FC and which type of component we are using for making this one. Usually if you take as a capacitor, what is the operation of capacitor? Capacitor, we know that in DC it block and AC, but AC it allows, but usually in AC it will not allow all the AC signal. Very important thing you have to remember that capacitor allows only high frequencies and it will block the low frequencies. So again question occurs, what high and what low capacitor will. Capacitor will always take one resistor with respect to charging and discharging. So depending upon these RC value, we can say that frequency it will allow or not. So if you take as a like this, the frequency formula, it is very common, 1 divided by 2 pi RC. According to this capacitor and resistor value, we will taking some particular frequency. The lesser than that frequency, the capacitor will block the signal, and greater than that frequency, capacitor will allow that. Okay, so the capacitor and resistance value will decide what frequency it has to allow and what frequency it has to block. So here my case, if I want to use low pass filter, low pass means the low frequency has to be passed, but capacitor will block the low. So what we will do, first we will take resistor and we will take capacitor after that, and we will make ground. Now what happens, the whole frequency coming here and high frequency passing to this direction and ground. Once high frequency passes and going to the ground, the left is low frequency in this side. So this low frequency we are passing. This is the structure of the any low pass filter if you are taking the example of RC circuit. So what happens in the high frequency or high pass filter? High pass filter, first we will allow the high pass here. So what happens here, high pass we will get from the capacitor and resistor for the just charging and discharging purpose grounded. Anyway, the low frequency will blocks here only, and this type of any RC circuit we are using for the high pass filter. Okay, so this is how the RC circuit can be drawn according to the your low pass and high pass. The ideal response diagram we are taken, but usually actual response, or we can call as a practically what happens when you are taking the example of the capacitor. We know that capacitor won't discharge suddenly. Here actually what is going on, the capacitor will charging this one and after that discharging, or it will take some time to from on position or gain position to zero position. It cannot get directly like that. So in actual response, if you are taking as a same diagram, so here we will take as a this one as it is gain in dB, and this is as usual frequency. So I will take as a this same response. So we will talk about something FC here present. So there is no doubt that up to this portion it is high. After this it will take to reach zero sometime. That means it will take this portion. It is not directly how we are shown. It will take some slope to reach here. Okay. Now one question arises. What is the slope this one? There is a many slope I can write. One I am writing something like this slope, or I can write a slope like this. This is the very delay, or I can write slope something like this very fast. So no, there is a many slope possible. This slope is known as roll-off rate. This is the very important concept in the low pass filter. This is nothing but how gain in dB and frequency rate. The slope is usually, you know that if you are taking any slope, so x-axis and y-axis ratio you are taking, same thing here also we are taking the ratio. So when you are taking about this ratio, that depending upon the different circuit, this roll-off rate is smaller or greater. If the slope is very thin like that, so this one is we call very high roll-off rate, and the actual response will getting very fast. But this one is if you take third one, it is very delayed. So this is all depend upon this roll-off rate. Okay, if you are using one capacitor and one resistor on this, so this usually roll-off rate will called as a minus 20 dB per decade. Okay, decade is nothing but 10 times of frequency. What is this means? The gain is, we are already told, it is we are taking in gain in dB. So usually it is nothing but gain by frequency is the our slope. So every 20 dB of gain, the 10 times of frequency will changes. This is the slope what we are getting for if one resistance, one capacitor present. Similar way we can take to this same circuit, once again we can connect seriously. So that what happens, instead of minus 20 dB, that depend on minus 40 dB. So if it is gone like that, this is actually the last one we called minus 20 dB something, because it will take lot of time to reach here. Then minus 40 dB means it is okay, and this is called minus 60 dB. So when you are talking about more capacitor resistor on this, this is called as a order of the filter. If it is one capacitor, one resistor is there, that is called as a first order. If it is two capacitor and two resistor is there, that is called second order. Always remember that there is a changes in first order and second order is this roll off rate only. Operation are same. It also passes the low pass and stop the high frequency. There is no difference in this operation, only changes in this roll off rate. So in first order we can say that 20 dB per decade is the roll off rate, and second order it is minus 40 dB per decade. So in second order we are using some circuit like capacitor and resistor. Again we are using capacitor, resistor. Okay, this is the two times we are using this type of circuit known as second order. And sometimes this also called as a single pole. First order also called as a single pole. Second order also called as a double pole. We will discuss more on this first order and second order circuit. Next we will move on the some particular parameter present in the low pass filter. First one we are calling as a pass band. Pass band of a filter is the range of the frequency that are allowed to pass through the filter with minimum attenuation. So in the low pass filter, whichever less than Fc is pass band, or less than Fc frequency will pass. Okay, similar way one more portion we are calling as a transition region. Transition region, in the ideal response we don't have that transition region. Transition region is nothing but change between one pass band to stop band. If you are taking in ideal response, we will directly take pass and stop band. Transition region we are not considering. When you taking actual response, we are taking as a slope. This slope area whatever we have, this area known as a transition region. So transition is nothing but one band to another band switching time or switching portion is known as transition region. Next, third one we can say about stop band. So stop band nothing but the particular range of frequency that have the most attenuation or that have the most block. So here stop band is nothing but greater than Fc value, and if you take as a stop band, high frequency will stop in the low pass filter. And fourth one we are talking about cutoff frequency. It is also called as a critical frequency, and usually we will call cutoff frequency as Fc. It defines that end of the pass band and normally specified at the point where which response from the pass band. Critical frequency Fc defines that the isolation between pass band and stop band. It is usually depend on resistor and capacitor. So formula of Fc usually we will take 1 divided by 2 pi RC. Now fifth term we are talking about bandwidth. So bandwidth means how much area we are passing. Here the area what we are passing, here if you take this starting point is 0 and another end is Fc. So usually we will talk about bandwidth is nothing but range from 0 to Fc. It's nothing but Fc. So cutoff frequency is the bandwidth of the your low pass filter.